Right, there we go. Cut. Okay, what we're going to try and do today is explain how energy is given out when methane burns in air, so the oxygen from the air, forming carbon dioxide and water. Many students have problems understanding the calculations behind this or what have you, and calculations can be difficult, so I'll try and make these as clear as I can. The premise is that we're going to burn this gas. So this is the reaction we're considering then, methane gas. This is CH4. The white balls representing hydrogen, the black carbon. Each of these grey structures represent a chemical bond, a bond between a carbon and a hydrogen atom. Now when they react together, they need oxygen molecules here. So the red ones are representing oxygen, O2, and the products that we make this way are carbon dioxide, CO2, and water, H2O. Okay, so we can see using these models that the equation is nicely balanced. That we have one molecule of methane reacting with two molecules of oxygen to form one molecule of carbon dioxide and two molecules of water. The G, remember, represents gas, and the L represents the liquid, the normal state of these molecules at room temperature and pressure. So, where is the energy coming from? Why are we feeling heat being given out when this reaction happens? To understand that a bit further, what we need to do is to consider these little grey strips. And what I'm going to try and do for you now is construct an energy level diagram to try and explain where this energy comes from. Okay, so I'm just going to clear the board first. I'll leave this here so it reminds us exactly what the overall reaction is that is taking place. So I'm just going to move all these pieces out of the way. Okay. This arrow here represents increasing energy, and I'm going to place my reactants at a point here on this diagram. Okay. Now my products I'm going to put on this side. Notice there is a difference in the energy level here. Okay, so my reactants are here at this level, and my products are here at this level. There's a difference in the levels. I'll come to what that means in just a moment, or how we get there. So the first process in this chemical reaction to get from here to here is to smash these molecules into atoms. As you'll know, if I turn my gas cooker on, nothing happens. I need to do something to make the gas light. I need to strike a match. I need to put some energy in to make that reaction commence. And what that does is effectively breaks each of these chemical bonds. And so I form one carbon atom, I form 1, 2, 3, 4 hydrogen atoms, and I have 1, 2, 3, 4 oxygen atoms. The same number of atoms here as I have here. A balanced equation. CH4 reacts with O2 two O2s to form one carbon dioxide and two water molecules. So I've had to put some energy in to these reactants to break them apart. So my energy goes in there. Now, these atoms are now going to reform new chemical bonds. In reforming those bonds, they're going to try and attain as low an energy level as they possibly can. So what happens is that they reform their new bonds at this lower energy level here, and we notice that the energy change between here and here is the same, so that energy as these bonds reform is used for breaking more bonds, so we can see that the reaction is self-sustaining once it's initiated, and the energy here released by forming these bonds is at this level here. So we can see that there is an excess of energy, this represented by this short arrow, which is given to the surroundings. That is everything that is not in this system here. So the system loses energy to the surroundings, and the amount of energy lost is represented by this short arrow here. In the next clip we'll have a look at what the numbers are that go with this, so we can put some numbers to these processes to help understand how we can get a value for the amount of heat energy released during the combustion of methane in oxygen.